I want to appreciate every one of you that have subscribed to our channel. Thank you for being a part of our channel. And for as many of you that are coming on board for the first time, I want to implore you to please hit the subscribe button right now. And I can assure you, you will get the best from this channel. Today we'll be talking about electrolysis, and we will be dealing with the calculation aspect of electrolysis, which basically deals with the second Faraday's law of electrolysis. Alright, now if you have not seen the initial video on the introduction to the formula that I will be using for today's class, you can just check the description or the comment section. You will see the link to that video. You need to see that video before you come over to see this video, so that you can easily understand what we are trying to, or what we'll be using to solve the questions. So I have some questions on the board. Now, for those of you that will be writing the JAM exam, or those of you that will be writing other exams that you have limited time, okay, computer-based test, you need to have a short method, a shortcut method that you can use to solve questions. If you'll be going through the longer process, it will save time. So for JAM, for example, you have less than 1 minute to answer a question. You have about 40 seconds to answer a question, or less than that. So the more cheaper or shorter methods you know, the better for you. Alright, so I'm going to teach you, we're going to solve these questions using a very short method that works with all of the questions. Now the first question here says 0.66 grams of a divalent metal N is deposited when a current of 1.35 ampere is passed for 1,500 seconds through a solution of its salt using inert electrode. Calculate the relative atomic mass of M. So we are asked to calculate the relative atomic mass of M, which we are going to do right about now. Come with me. I taught you the formula which you are going to use. So, and that formula is, when you go to the mosque, you see a Quran, you see a wall, and you see the number of female. Like I said, go check the description. You will see the link to the video where I explain all of this, but this is the formula. So M equals Q ram over NF, where your M is equals to the mass deposited, your Q is the quantity of electricity, or quantity of charge, quantity of electricity, electric charge, quantity of electric charge, and that Q is IT, according to the first Faraday's law of electrolysis. So your quantity of electricity or quantity of charge is equals to current in ampere, which is I, times your time in seconds. Alright, your I equals to current in ampere, T is time in seconds. Alright, your RAM is the relative atomic mass. The N is the charge on the element that is being deposited, not the number of moles. It is the charge on the element that is being deposited, and your F is a constant, which is 96,500 coulombs. So this is what we are going to use to answer the questions we have on the board. So let's answer the first question. Anytime you are solving a question, the first thing you want to do is to write out the parameters given. So we're going to state the parameters given. 0.66 gram, so the mass is 0.66 gram of a divalent metal. Divalent metal means a metal that has a valency of 2. So that means the oxidation number of that metal is going to be +2. For example, if you look at elements in group 2, like calcium, like magnesium, right, they have valency of 2. They have 2 electrons in the outermost shell, and their oxidation number is +2, because they will lose 2 electrons, or they will give out 2 electrons to attain stability. If you have not seen my video on how to determine the oxidation number of an element, please, you can check the description. I have dropped the link to that video. Alright, so when you say an element is divalent, that means it has oxidation number of +2. So that means our N is 2. Alright, deposited. So 0.66 gram of a divalent metal is deposited when the current. So our I is 1.35 ampere. For the time is 1,500 seconds. Through a solution of a salt using inert electrode to calculate the relative atomic mass. So we are asked to calculate the relative atomic mass. So you don't need to go through a long process. Just make your relative atomic mass the subject of formula. In case you don't understand how to make a particular value, okay, subject of formula, I also have done a video on that. Check the description. You will see the link to how to determine or how to make how to find this or to change the subject of formula of an equation. Alright, so if you are going to make RAM the subject of formula, M equals Q RAM over NF. When you have to cross multiply, when you cross multiply, you have MNF equal Q RAM. And so you divide both sides by Q. Alright, this cancels this, and so your RAM is going to be MNF all over Q. So that will be a short method to answer this question. So let's slot in the values. M is 0.66 times N is 2 times 96,500 divided by Q, and our Q is IT, that is 1,500 I. That's the T times our R, 1.35 ampere. So if you slot in your value, the relative atomic mass is going to be, answer is going to be 62.9, which is approximately 63. That is the answer, the relative atomic mass. So that means the element, the metal, is likely going to be copper, because copper has oxidation number of 2, and the relative atomic mass of copper is 63.5. So copper is likely going to be the answer. So that brings us to the answer for the first question. Now let's go to the second question. A current of 3 ampere passing for 4 hours through a molten tin salt deposits 26.6 grams of tin. What is the oxidation state of tin in the salt? And you were given the relative atomic mass of tin to be 119. Said what you want to do is to first spell out the parameters given. So number 2, a current. So your current is 3.0 ampere. The time is 4 hours. So you convert that to seconds by multiplying by 60 times 60. Okay, so that will be 4 times 60 times 60. That's 14400 seconds. Okay, so that is the time. So the time is 14,400 seconds. And then through a molten tin salt deposit, then you have the mass to be 26.6 gram. See, what is the oxidation state? So N is what we are looking for. So without wasting time, you make N the subject of formula. So your N is equals to Q RAM over MF. So our N is going to, let's slot in the value. Q is IT, so your I is 3 times your T is what? 14,400 times, what is our RAM? Our RAM is 119. Remember, the RAM is 119. We're given. Okay, that's from the question here. Alright, multiplied by 119 divided by, what is the mass? Our M is 26.6 times 96,500. So if you slot in the values, Your N is going to be plus 2. It's going to be 2. So our N is equals to plus 2. The third question is a little bit dicey. Alright? So, but let's look at it. The question says, calculate the mass of lead that will be deposited from an aqueous solution of lead 2 salt by the same quantity of electricity that deposits 2.70 grams of copper from copper 2 sulfate solution. So, the best way to answer this question is to answer the latter part of the question first. Once you get the quantity of electricity, then you answer the form. So try to understand the question. The question says calculate the mass of lead that will be deposited from an aqueous solution of lead 2 salt. So this is where the key is. By the same quantity of electricity that deposits 2.7 grams of copper from copper sulfate. So what that means is first calculate the quantity of electricity, alright, from the values given for copper sulfate. So that same quantity of electricity will now be used to calculate the mass of lead in lead 2 salt. Is that okay? So let's try to solve it. Starting with the second, they said we are calculating the quantity of electricity, Q is unknown, alright, that deposits 2.7 grams, so our mass is 2.7 grams of copper. So copper is copper 2, therefore the charge for copper will be 2 sulfur. And you remember that the relative atomic mass of copper is 63.5. Yes, 63.5. What else? We'll be giving the mass. So your N equals to Q ram over NF. So we want to find Q, we make Q subject of formula cross multiply. MNF equals to Q ram. Divide both sides by ram. This cancels this. So your Q is M and F all over the relative atomic mass. So if you slot in the values, your Q will be, the mass is what? 2.7 times the number of charges 2 times 96,500 coulombs all over the relative atomic mass is 63.5. So if you solve that, punching your calculator, the value for your Q is going to be 06.3 coulombs. Alright, that is not the final answer. That is the quantity of electricity that deposited 2.7 grams of copper. So the question now says calculate the mass of lead that will be deposited from an aqueous solution of lead 2 salt by this same quantity of electricity. So now we want to calculate the mass of lead. So mass of lead is unknown. The molar mass, the gram of lead is 207, right? 207. What else? Lead 2 salts. That means the charge will be 2. N equals plus 2, right? And of course the quantity of electricity remains the same here, 8206.3 coulombs. So we are asked to find N. N equals Q ram over NF. 06.3 coulombs, right? So since your N equals Q ram over NF, if you make so you're asked to find the mass deposited. So the N is going to be Q, which is 8206.3 times the ram 207 all over charge is 2 times 96 500. 8.80 grams. So that is the mass of lead that is deposited by the same amount of electricity that deposited 2.7 grams of copper. Now let's go to the fourth question, number 4. Now I'm going to allow you to answer this fourth question. I will give you the time. You can pause this video, do your own calculation, and let's see if your answer will be correct. The question says a solution of copper sulfate is electrolyzed with a current of 6 ampere flowing for 5 hours calculate the mass of copper deposited. So you have the time, you can quickly just pause this video and do your calculations and let me know if your answer is correct. Alright, welcome back. Let's answer the question. Number 4. So write out your parameters given. The solution of copper sulfate is electrolyzed with a current, so the I is 6 ampere, flowing for time is 5 hours. So we are going to convert that to seconds. So our time will be 5 times 60 times 60. So that is 18,000 seconds. And then we're asked to find the mass. We're given the relative atomic mass of copper, 63.5. And your F is 96,500. So your N is Q run over NF. That will be your Q is IT. That is 6 times time, 18,000, multiplied by the RAM is 63.5, all over the number of charges 2, because it is copper, alright, copper, so our N is 2. So 2 multiplied by 96,500. So if you slot in the values correctly, 35.5 grams, or approximately 36 grams. So I believe you got that answer correct. So that brings us to the end of today's class. My name is Coach Paul, and I want to welcome you to our platform, to our channel. This is a channel where we break down app topics for you. We give you shortcuts, short methods, how you can quickly solve questions within a short period of time. All right, and we deal with topics in mathematics, physics, in chemistry, and in biology. Alright, so do well to post your comment in the comment section. If you have a question for me, drop the question in the comment section. And if you have not subscribed, do well to hit the subscribe button. And remember to hit the notification bell so that you can be notified when we drop a new content. And please do well to share this video with your friends, colleagues. Thank you very much for being a part of today's class. See you in the next class.